Okay, so I have, welcome to Sound System Operation. Today we're talking about small analog mixers. I have a couple here. One that is really dusty and I lost the power supply for and I can't turn it on. One that is not dusty and is not particularly old and I do have a power supply for. So this is the one that we will have sound going through today. But this one over here has some features that the other one doesn't, and so I wanted to have both of them out here just so we can show. So it doesn't matter what they are. That's not the point. I think this one is from Sound. I think they're both from Soundcraft, actually. Yeah, they're both from Soundcraft. That doesn't matter. So the first thing I want to talk about is let's just understand in principle what these things do. Okay, the mixer takes a lot of sounds and puts them all together and sends them somewhere. So you could have a lot of sounds, and those sounds could come from lots of places. They can come from microphones, they can come from recording devices, they can come from processing devices, but you'll have lots of sounds coming in, okay? And usually you only have, well, the paradigm for most mixers is you have one sound system or one speaker or set of speakers that all the sound comes out of, okay? And so you got to get all those sounds that are separate to come out of one place. And so the mixer is what mixes them all together into one place and sends them to that thing that reproduces it, okay? But there are a lot of issues with doing that. So we're going to talk about them. So you can stand up and get closer, or you can stay, or whatever you want. But we're going to get into the weeds here, okay? So this starts with inputs, okay? And if you look on the backs of these, which you can't really see it on the video, but there's a whole row of connections. If you want to come back and look, you can. So there's a couple of different types of connectors on here. So these ones are called XLR connectors. Strictly speaking, they are XL connectors. The R stands for the rubber ring that goes around the connector. Okay. But now they all have the rubber ring, and that's not a novelty, so now we just call them XLR. So, but there was a time when the rubber ring was a new thing. So like, well, it's an XLR. All right, and that was very exciting. Interesting thing about the XLR is it is what's called balanced, or it can carry a balanced signal. What that means is that we tend to shoot sound long distances across a room, down a cable, okay? There's lots of things that can happen to it along the way. Namely interference. So there's lots of just garbage in the air, electromagnetic interference and stuff going on in the air that can come from lots of things. And that can influence that signal that's running down that electrical wire. And if it's only going a foot or two, it's usually not, a big deal. But if it's going to go a long ways, that risk is huge. Picking up a lot of that garbage. And it manifests itself as noise usually. Little hissy, noisy stuff, okay? So one of the ways that we deal with that is we do what's called a balanced or a differential signal. And the idea behind this is we actually send the signal down the wire twice, okay? So it goes down on one wire and it's also going down another wire. And then both those wires share what's called the common, okay? Because it's an alternating current. So it alternates between that common, okay? So both share the common, but the first one is in what's called a positive polarity. And what I mean by that is if you look at the best way to understand polarity is to think about what the speaker does, okay? So here's the loudspeaker. This little driver here pushes and pulls on the air, right? And that's what makes sound. So when it pushes, that's a positive pulse. When it pulls back, that's a negative pulse, okay? So when something is positive polarity, it's doing push, pull, push, pull, push, pull. The other wire is taking what's called an inverted copy of that signal, negative polarity, which means that signal that goes push, pull is now going pull, push, pull, push, pull, push. Okay? Why is that important? Because when you sum those two things together, they cancel out. So if one signal is pushing at the same time that the other signal is pulling, and then you mix them together, it cannot be both pushed and pulled at the same time. And so it just, nothing happens. Okay? So how does that help you? Well, here's where it gets interesting. So you send this signal down the wire, 2 copies of it. And one copy is positive polarity, the other is negative polarity. And then it encounters noise and interference and all that kind of stuff, and that like gets into the wire. And you're like, great, now I got noise. Well, guess what happens? When it comes into that XLR cable, into that XLR connector and into the mixer, that negative polarity copy essentially gets inverted again. And so now you've got 2 copies that have your sound at the same polarity, which means they're both doing push, pull, push, pull, push, pull. But guess what happened to the noise? The noise got onto both wires. And so now the noise is inverted polarity and positive polarity. And so when the mixer sums them together, what happens to the noise?
It gets
goes away. Okay? So, this is why we really like balanced signals. Because balanced signals allow us to shoot the sound all the way across the room, and we don't have to worry as much about the noise. And the other thing we do is we have a shield, a little metal shield that circles those wires. And that usually, in a balanced signal, is also the common. And that's supposed to collect some of that garbage too and shoot it into the electrical ground, okay? So hopefully you may not even get very much noise into there in the first place if the shield is good. But in order for this to work, you've got to get the noise introduced equally onto both wires. Or that invert polarity and sum and it goes away thing doesn't work. So they have to be perfectly, that noise has to get on both wires. So that means the way that we do that is the wires end up getting twisted together as they go down that cable so that all the noise gets introduced equally on both sides and everything. And you want to keep that as long as you can. And the nice thing about an XLR is even when you break that wire out, it still keeps the wires perfectly parallel all the way through the connector, okay? And so that helps, keep that signal rejection much stronger. Whereas you can also, on both these mixers, you have what's called a 1/4 inch phone, whatever you call it. There's lots of names for it, but I just call it 1/4 inch. Connector here that can also take a balanced signal that has a tip ring sleeve. You've seen those that have tip ring sleeve? I'll show you one in a minute. That can also carry a balanced signal, positive, negative, ground. The downside is that connector breaks it out and they don't stay parallel the whole time, which means there's a very slight potential for some noise to get through. Probably won't happen. It's probably one of those things that I get worked up about that I don't have to get worked up about, but in principle, the XLR is better. The XLR is also better because it locks, which is super better, okay? So, any questions about that so far? Everybody okay? Anybody feel like they got to write anything down? You're welcome to do that if you want to. Okay. Great, it's in, right? We put it in. Then I'm hoping you all understand this concept, but if you don't, I can expound upon it. But the idea that, there are channels on this console, okay? And each input represents a different signal path that then gets mixed together, okay? So this mixer has 12, single channel inputs on it, okay? Plus it has a couple of 2-channel inputs. This one has, looks like 8 single channel inputs on it, okay? So I can put 8 separate sounds into this one. I can put 12 separate sounds into this one, plus I can do a couple of pairs, stereo pairs if I want to, okay? Great, it's in. We got sound in. Now what?
Make
Get it back out.
Eventually, we got to get it back out, but we got to do a whole lot of stuff to it first. Now, the first thing it encounters is what's called the preamplifier. We tend to send the sound around the room at very, very low voltages. And especially microphones. Microphones are very, very low voltage. And every piece of sound equipment has a certain amount of what's called self-noise, which is like everything, there's a certain amount of little hiss that just is a byproduct of moving sound around on an electrical circuit, okay? And if you do things the wrong way, you'll hear that hiss. And maybe you've heard some hissy sound systems. You've heard the little hiss coming out of the speakers. And maybe you've had some people say, oh, that's just amp hiss. Can't do anything about it. It's like,
yes, you can.
No, you absolutely can do something about that. And no, you should not be hearing that. Like, you are absolutely doing something wrong. And the thing that you're doing wrong is you don't have a sufficient signal-to-noise ratio. And the idea there is you want, the noise, it's true that the noise is there, and it will always be there, and you can't make it go away. That part is true. But what you can control is how much difference is there between your sound and the noise. You have control over that. If there is not a very big difference in loudness or amplitude or whatever between your sound and the noise, then that's when you notice the noise, okay? But if you can make it so there's a big difference between your sound and the noise, then when you make that sound come out of the loudspeaker, you hear your sound and the noise is so quiet that it may as well not be there. You don't hear it, you don't notice it, okay? So what the preamplifier does, the preamplifier is usually the most expensive part of any mixing console, because it is an electrical circuit that has a superpower. And the superpower is that it can amplify a low voltage signal without amplifying noise. They usually have a very low self noise. And that's why they're so expensive, is they're engineered to have very low self noise. We can't put that kind of circuit everywhere, or the mixing console would just cost a gajillion dollars and no one would buy it. But we're going to put it into the preamplifier. So the preamplifier usually has really, really low noise. And so it can take that low voltage audio signal and it can amplify it. It can make it more or louder or higher amplitude without introducing a significant amount of new noise. It's never no noise, but it's not very much, okay? And so when someone says that this mixer has good preamps, usually what they mean is, well, you can turn that preamp up really high and the sound is still clean. It doesn't, you don't hear a lot of noise. Really cheap preamps, you turn it up a lot and you get noise, okay? Good preamps, you don't, okay? So when people say it's good preamps, they just mean, yeah, you can crank it and you don't have to worry about the noise. It still sounds good, okay? So how do you know how much to turn it up to? Well,
Listen to it.
there is a rule, and this is one of those things that the people on YouTube might say different, but you're going to listen to me instead. So this red knob, this is how you control the preamplifier, okay? So all the way down is the least amount of amplification, all the way up is the most amount of amplification, okay? So what do you set it to? Which one am I on? I'm on this one, okay. The answer is the highest that you possibly can without clipping it. And clipping it is the voltage, like there's a limit to the electrical circuit. Mm-hmm. That voltage can only be so high and still run down that circuit. And if you allow the voltage to exceed that, then the signal gets chopped off and it sounds really bad.
So is there like the color meter where it's like yellow, green?
Yeah. So you can do this by ear, but you can also look at a meter sometimes. So let me show you this. I'm going to hit this little button here. We'll talk about PFL in a minute. But what that'll do is that'll let it show it up on the meter. Yes. And I'm going to talk into this thing and talk, and I'm going to keep turning this up. I want it as hot as I can get it without clipping. You see the clip?
Yeah.
I don't want that to happen. Never, ever want that to happen. On an analog console, you can sometimes get away with a little bit of clipping, and that's because of all of the, I don't know, I call them the roadies with mullets, which are the people that have like been touring with Leonard Skinner and everything for, 50 years or something, and they usually have mullets, and I'm obviously being a little snarky here, but there's a contingent of those folks that really judge the quality of the mixer based on how good it sounds when all the clip lights turn on.
Wow, okay.
Okay? And it's like, this is a great console. I flatlined it, and it still sounded great. So there's two reasons why it still sounds great. One is that analog circuits are much more forgiving of slight clips than digital circuits are. You don't hear quite as much audible distortion as you do with a digital circuit. A digital circuit, when that clips, like, you're screwed.
That's it, yeah.
But with an analog circuit, a little bit of soft clipping, doesn't always have a problem. But now put yourself in the mind of, is that Graham Blythe? Who designed this mixer,
yeah.
and signed it. Put yourself in that person's head. And you were trying to make a mixer that people are going to want to buy. And you know that there is a strong contingent of your customer base that are going to judge this thing based on how good it sounds when the clip lights turn on. And you have the ability to make this thing do whatever you want. What would you do?
You're gonna make them turn on sooner.
Yeah.
I'm going to make the clip lights turn on sooner. I'm going to make the red light come on before the signal actually clips. Okay?
That's smart.
That happens.
If it works, I guess.
Every analog console I've ever encountered in my life, the red light comes on 6 dB before the signal actually clips.
Well, good.
Okay?
So should you factor that in when you're setting your preamp?
Probably not, unless you have the ability to figure out what that gap is. And when you take my system engineering class, I'll teach you how to do that. How to figure out what the gap is between when the light comes on and then when it actually clips. But there's usually some room there. And some of the digital mixers do this too. So there's degrees of red light. There's the red light barely coming on and it's not actually clipped yet. And then there's the red light coming on and it's actually clipped and you can hear it, okay? So this is all by way of saying that, yes, by all means, look at the red light, but understand that that is an imperfect measurement, okay? You definitely don't want it to clip, ever. Clipping is always bad. It's definitely always bad in digital world. It's almost always bad in analog world. But in digital world, it's definitely always bad. You never want that. But you also want your signal to be as high as you can possibly get it before you send it down the rest of that circuit. Because that's how you keep that signal to noise ratio really high. So you want to turn that up really hot, if you can. Turn it up as high as you possibly can.
The preamp.
Yep, without clipping it. And if you see it clip, great, back it up. And you're gonna put the microphone on the performer, the musician or something. You say, all right, play your loudest thing. Because that's the thing that'll clip. right?
Okay.
Play your loudest thing. Let me hear what that is. And you're like, okay, that's the loudest thing. Great. Okay, now here's what I have found. Whatever a performer thinks is their loudest thing in a rehearsal is somewhere between 6 to 10 dB quieter than what their actual loudest thing is going to be when they have 1,000 people out there really excited about what they're doing. They're gonna dig deep and they're gonna find another 6 to 10 dB that they didn't tell me about in the rehearsal. So when I say, give me your hottest thing, and they give me their hottest thing, and I go, okay, I get that not clipping, I usually turn it down
Yeah,
10 dB. More, because I know when the show comes on,
it's gonna be loud.
it's gonna be more, and the first song, or the first whatever, is gonna be clipping like crazy. Right? So, a little pro tip. Whatever they say is the loudest thing is not going to be the loudest thing. So here I'm talking, and it's clipping, and I'm going to make it not clip. Okay, great. It's not clipping, and I'm talking into it, and it's just fine. Okay? There you go. That's how you do it. And now I can talk into this, and you hear it. And do you hear any hiss? Nope, no hiss. Amazing.
Can you put the volume up so we could hear what the hiss would sound like?
Yeah, so let's do this. Let's see if I can make it hiss. I'm really bad at making bad sounds, so.
There it is.
You hear it now?
Yeah.
Check. You hear the hiss?
Yeah.
And then you would fix that just by lowering the top red knob.
Yeah, so I'm turning this back down, bringing this down, and I'm gonna bring this up. Because this is the thing that I can make it louder without getting more hiss.
Okay, yeah, because it's the preamp.
Because it's the preamp, and the preamp has a superpower. That knob, you turn that up and it amplifies hiss. This knob, you turn it and it doesn't amplify hiss.
So would that simply be because of like you just explained, the preamp has to do with the microphone, but then like that speaker is itself, like its volume, or,
It's just a cheaper amplifier.
okay,
It's an amplifier as well, it's just cheap and noisy.
got you.
And it can be cheap and noisy because usually by the time it gets to there, it's already been amplified and fixed in there. They're assuming that you've already fixed it. And so they don't need to sink a lot of money into that amplifier.
Got you.
Because you're hopefully never gonna crank it like that.
And you said that they, the preamplifier doesn't come on every board? Or does?
Most consoles will have preamplifiers.
Are there any that we're gonna be working with that will not?
So, maybe. Because you might run into some consoles where you don't have to adjust a preamp, and that's just because it's what's called a line level input, where maybe you're already working with a signal that has been amplified already by something else. Maybe you have an external preamp, or it's a line level source like this playback machine that I'm using, and you may not need to do something with it because it's already been done, in which case you won't need that. But so some consoles will allow you to assert some inputs that don't necessarily have preamps on them, or at least not preamplifiers that you have control over. They might be just fixed gain or something, okay? So you will see that from time to time, but not often, okay? Other questions?
So is the difference between gain and preamp just what you call it, or is there
So
a functional
the
difference?
preamplifier is the circuit.
Okay,
Gain is the result,
okay.
okay? Gain is the result of using a preamplifier to amplify.
Okay.
You get gain. Gain means more. You gained something. I gained more sound by manipulating the preamplifier. Okay? So yes, sometimes you'll say turn up the gain. That's a bit of a misnomer.
Okay.
I try to say turn up the preamp, but some people say turn up the gain. What they mean is turn up the preamplifier.
Okay,
Or they might,
so they're like one and the same?
yeah, it's using the wrong word to describe something, but
Okay,
technically, it makes a certain amount of sense.
got you.
Because you're just talking about the
We all know
result.
what they're saying.
Yeah, it's like, I need more gain. They're looking for a result.
Uh-huh.
And so they say turn up the gain, but what they really mean is I need more gain,
Okay.
right? Other questions? You with me so far? Is that cool? All right. Well then. So, there's your first secret. Okay? I just told you something that the people on YouTube aren't going to tell you.
The preamp?
We're already getting.
Except
Yes.
you upload it.
Except,
Yes.
yeah, except you.
Except that's
And I pick fights with people online about preamps all the time.
Oh, Lord.
And I'm pretty sure I'm right.
Pretty sure I'm right.
But I do pick fights with people about this. Okay. There's another thing here. Actually, before I get to the other thing, let's get to your question. I want to expound on your question of like, what is there ever a scenario where we don't have a preamp? I told you that's rare, but I do want to illustrate a point here. So, okay. So I've got a multi-track going here.
Nice.
And let me fix something. And then I'm going to show you a problem that you will definitely encounter sometime in your life. Okay. So I have 8 channels of musical instruments coming into this mixer, channels 1 through 8. Faders are down, and one thing you might notice is, boy, I've got an awful lot of red lights turning on.
That's not really.
Okay, that means it's might be clipping. Okay, let's look at our gains, or our preamp, right? They're all the way down, and it's still clipping. Let's listen to it. Let's listen to the clip. Hear that rattle? Here's that. That's not good. Yeah, the bass, you can definitely hear the distortion. Okay? It's not supposed to sound like that. It's definitely clipping.
Supposed to be smoother.
So what's going on, Jason? The preamp's turned all the way down. How is it clipping?
You gotta turn
Maybe the mains are too high.
Well, no.
the.
It's here. It's clipping here. I've got the preamp turned all the way down and it's still clipping on the input. So what's that tell you? It tells you that the signal on this wire is louder than this preamplifier can handle even at its lowest setting.
Okay.
Okay? So I'm running too hot of a signal into that preamplifier. Well, what's going on there? How is that possible? Don't these people talk to each other that make this equipment?
So you gotta change the settings on that?
They do not talk to each other, first of all. However, there are some things that manufacturers more or less agree on, and one of them is what's called nominal operating levels. So this should not be possible to happen, and yet it has. And
And it's called what?
nominal operating levels.
Nominal operating level.
That's like a volt, you know, it's like we generally as a sound people kind of have a agreement where we say, you know, this is how many volts an audio signal is going to be.
Okay.
Okay? And most people follow that, okay? I would expect that Yamaha, who makes the output that is generating this signal that's going to there, they probably know about those nominal operating levels, and they are probably following them. And I suspect Soundcraft knows about them, and they are probably following them too. And yet, we have clipping. So what's going on? Well, there's more than one nominal operating level. Okay? And there are actually 2. We have used 2 of them already this morning. One is called microphone level, and one is called line level. Now,
Line level?
line level.
And that's the line in the console?
No, it's just 2 different things. There is a reason that we can get into if you want, but we'll talk about it more
Later
when you take sound system design. But the nominal operating level for line level devices, which is like things that aren't microphones, is 1.23 volts. So 1.23 volts is the nominal operating level for professional line level equipment, professional like balanced, that we talked about balanced. Balanced audio at line level is 1.23 volts nominal, and nominal meaning like when the meter hits unity, or the meter hits 0. That's 1.23 volts. Also known as plus 4 dBu, which interestingly enough, you will see on the back of this monitor, it says plus 4 dB. Why plus 4? Why did they put a detent at plus 4? Because plus 4 dBu is 1.23 volts, which is the nominal operating level for line level equipment, of which this is a line level device. Okay?
Okay.
So great, 1.23 volts, awesome. I guarantee you that that's the nominal operating level that this Yamaha interface is using. 1.23 volts for 0, well, plus 4 dBu, you know, and if you look at our meter here, this meter hits 0 in the middle. So it's minus 20 down at the bottom, 0 in the middle, and plus 18 when you hit the red. So you can, on a line level signal, it can definitely go hotter than 1.23 volts, but the nominal level, the 0, would be 1.23, okay? And so the circuits are designed for that. A microphone level signal is quite a bit less than that. Its nominal operating level is measured in millivolts, not volts, okay?
Millivolts?
Millivolts, as in thousandths of volts.
Okay.
It's a lot less. And there are some reasons for that that are important to people who make microphones, that don't need to really be important to us because we don't make microphones. We just use them. So but you need to understand that the voltage that comes off the back of this microphone is going to be significantly less than the voltage that comes out of that line level interface in that rack over there. Thus, the world invented preamplifiers. Because ultimately, this mixer is a line level device. 1.23 volts is where this mixer is happy. So what the preamplifier is doing is it's taking this tiny voltage and turning it into a 1.23 volts-ish signal so that it can run around the rest of this thing and into this person and be happy. Okay? So that's what the preamp does. But I got a thing that's already done it. That interface is already doing line level. And I'm running it into a preamp that is designed to amplify it. I don't need to amplify it. Well, there are a couple of ways around this problem. There's about a 20 dB difference between line level and mic level. Okay? And if you look on this console that I don't have the power supply for, you will see it has a button here called line, and it's right next to the preamplifier control. This could do a number of things. One of the things it could do is it could automatically duck that signal 20 dB. Could do that. Probably isn't actually doing that. What it more likely does is bypass the preamp.
Okay.
Okay, it allows the audio to go around the preamp and then continue along its way. Another thing it could do is it could actually switch you between two inputs. So the XLR input would be used for the microphone level signal, and then the 1/4 inch input would be the way that you get the audio in that doesn't have to go through the preamplifier. Okay, so this button could just say, use the XLR when it's up, or use the 1/4 inch when it's down. Okay?
XLR when it's up or 1/4 inch when it's down.
Yeah. This console, however, has no such button.
Right. They have the 4.
At least that's what I thought, so. Yeah. Oh, no, that's something
No,
for them.
they have other things.
That's 48.
Yeah, that's something else we'll talk about in a minute. So this has no such button,
Gotcha.
which tells me, and if you look up in the manual, I'm confident that it'll say this, that they're going to say that, yeah, so you can't bypass the preamp for the XLR input. And I need to bypass the preamp. So how do you bypass the preamp? You use the 1/4 inch input.
Okay.
Okay, so
So for digital console, would it kind of be the same as far as the quarter inch would go, or would there be a button for it?
It depends on the console. So some consoles will have 2 inputs. Some of them just have automatic switching preamplifiers that will sense, when you need to, they have a really big range, and they'll switch between that line level and mic level.
Okay.
Just depends. But now I want this to not clip anymore, so we need to get some quarter inches. So come over here, I'll show you where they are. These have XLR socket connector to a quarter inch tip ring. Positive, negative, okay. One. Two. You got it? 3, 4, 5, 6, 7. 8. All right, so somebody take those and stick them in the right place. So bring them on over. I don't have to do it. You guys can do it.
Everybody wants some?
So what you want to do is you want to take out the XLR. You want to stick one of those adapter cables on the end of it, and then plug the quarter inch into the line input. Look, it even says line. It says mic next to the XLR and line next to the quarter inch. They're trying to help you out here.
So,
Yep, so go into the line, and then plug this into there. Da-da-da! Okay. Look at that.
can we start putting them up?
See, no clipping now.
Go. And then line,
Very good.
and then this one goes into this.
Let's remind ourselves what that distorted bass sounds like. Okay. So then when we do it, we'll listen to it again. It won't be distorted anymore.
And then line.
Sweet. All right, help us out here, Cal. We're making good sound. It's gonna get better now. Just need the right cable.
I'm so excited to do sound.
We're gonna learn the right way to do stuff. That's my goal.
All the red dots are the.
Look at that.
Yay.
The red lights are going away, and the roadies with mullets are like, oh.
I noticed there's also the instrument connector, so I guess that's on a different voltage as well.
Oh, interesting question. It says IN, there is a connector on here that says INS. That is something else.
It's not.
It is not, does not mean instrument. It means something
I
else.
always thought of my instrument.
It means insert, which we will talk about next week.
Cool.
Okay? Okay, hey look, no more clip lights. There's our bass now.
It sounds like it's.
Much better.
Right.
No more distorted bass. Okay. But look at this now.
It's low.
Now I've got headroom.
You can,
So that preamp control still works. So this is either a different preamp circuit that I've now accessed, or it's what it's probably done is it's done a minus 20 dB off the top voltage reduction, and then runs it through the preamp, okay? So it could be that, we'd have to look up the circuit to see. But same process, I'm gonna crank this until it doesn't clip. Or at least until the red light doesn't come on, which may or may not mean it clips. Great, perfect. Somebody do this one. Push the PFL, which will let you see the signal on that meter. Yep, there you go. And then turn that up until that clips, and then back it off. Clipped for a second there.
It's not clipping.
Check, let's wait till the end of that little run.
Okay.
There it comes. Oh, a little bit, back it up just a little bit more. Okay, perfect. So, here's the interesting thing. A lot of people ask me, well, where's the right place for the gain knob to go, or the preamp to go? It's like, I don't know.
It's on my phone.
It depends. Depends on the signal.
Gotcha.
Okay, there's no right or wrong place to put it. That is always right. Some people say, oh, just put it at 12 o'clock, forget it. It's like, no!
Right, yeah.
No!
So once
You spend a lot of money for that knob, like use it for a reason, you know? Okay?
So like standing right here watching it, like when it gets to the end, it still kind of peaks a little bit. But whenever you're done, like figuring it out, do you just press this again so that goes?
Yeah,
away?
so now you don't see that. Yep,
Gotcha.
you got it.
Okay.
Now, very good. All right, somebody else want to do one? Let's do this one. Number 3.
I have to turn the PFL on?
Yep, just so you can see that meter. Ooh, there we go, we got a clip. There it is. All right. Great, perfect. Excellent. Somebody want to do one of our piano channels? Eric? Very good. So I'm going to do the next piano channel because I want you to hear something. Let's see if we can figure out when this actually clips. You hear it clipping a little bit? I don't hear the clipping as much anymore, even though the light's coming on. See how that works? They're making the light come on a little sooner. And in Sound Gym, there's a game in Sound Gym where you practice hearing clip distortion.
Yeah.
Okay? So you want to get really good at that one because your ears are better than that meter. Okay?
I'm currently very bad at that.
Yes, try to get good at it. Okay? All right, somebody come do 6.
That was so terrible.
Sound clip, that is something.
Maybe the original one. That sounded exactly like it.
By the way, you can do this without even turning the fader up if you want. It's just, this is just math.
I don't like me.
This is from the book. Eric found this, then we used it for one of the demos in our book. I don't know where it came from. Okay, let's see. We need to do that guitar. Has everyone had a chance? Oh, Connor, I guess. Do this one. Okay. And then, let's see, we got one more here that, we'll do this one real quick. This is already distorted, so this is a hard one to do by ear. They distorted it on purpose, you know? Okay. Now, we now have clean signal. It's amplified, and we'll just keep an eye on these clip lights. Like this one just clipped a little bit right here, so I'm going to just kick it down a little tiny bit. But so you just keep an eye on that, and if, oh, there, that clipped just a little bit. I'll take that down. So if you ever see it clip again, just like reach up and knock it down a little bit. But here is what I hope. Maybe you've put this together, but maybe you haven't, which is that this knob has nothing whatsoever to do with this fader. Okay? And there are people on YouTube, and there are people who have been touring with Leonard Skinner or whatever for years or something, who will tell you that, well, you know, you really want to mix, you really want these faders to be up here, because that's where they sound the best. And so in order to have them be there, you really sometimes you'll need to turn down this preamp. Do not listen to those people. Those people are making noisy sound, okay? Now it is true that if mixing a show down here in the tiniest last centimeter, that's not a fun thing to do. And it could very well be that, you know, if you do this right, that, you know, I don't have to put this up very much before I feel like I've got it, right? And if I take these up to where I really want the faders to be, I'm kind of feeling like the show's too loud, right? That is not a reason to turn down your preamplifiers. That is just a sign that you spent too much money on your sound system. Or you spent too much of somebody's money on that sound system. It's too big. You don't need that much sound. And if you're in that scenario, what you want to do is you want to go to the last thing in the signal chain and turn that thing down. So I'm going to come to the last thing, which is this. This is where the amplifier is for this monitor. And I'm going to turn this down because this is the cheapest amplifier in the system. And I want it to be as low as I can get it anyway, right? Because I don't want it amplifying any more of its own noise than I can get away with. So I'm just going to turn this thing down. And then, let's see how far I can get now. Still got a little room. Okay. Now I got a show. Now I can mix, and I can put the faders where I want them. Okay? And it sounds clean, there's no hiss, everything's great. I'm gonna get paid a lot of money for this show.
Oh, yeah.
Okay? This is the secret to my success, is those preamplifiers.
Wow.
Crank those as high as you can get them without clipping. Never clip. I'm not saying clip, don't clip, never let it clip, but get it as hot as you can get it without clipping it, for sure. And then go to the last thing in the signal chain and turn that down if you have to. But that's...
Sorry, the last thing on the signal chain.
Yep. And the signal chain is just like the chain of devices that's carrying the signal through your sound system. And the last thing is the amplifier inside those loudspeakers, okay?
So in this pace, like if we were in a show, in a theater, the last thing would be like the speakers in the theater.
It might, if the loudspeakers in the theater have amplifiers built into them, then yes, you would go there and turn it down.
Like
if-
say maybe like on stage wedge or something.
If that's where, if there is an amplifier gain on there, if it's not, it's probably in an amplifier in a rack somewhere, like a power amp, and go turn down those input gains.
Okay.
Right? Okay, there we go. Any other questions? All right. Yes.
I mean, this isn't a situation right now, obviously, because we're not using microphones, but
Yes.
when we use microphones, how does feedback play into all that? You still set the gain knob as high as you can, yes?
Absolutely.
And then deal with it later in this.
So feedback is a different thing, and we will talk about that in great depth in the sound system design class.
Okay.
But feedback is a geometry problem,
Okay, right.
and you solve it with geometry, not with knobs. Okay?
Excellent.
And so, yeah, don't obliterate your gain structure in order to solve your feedback problems. Don't ever do that, okay? But there are way better ways of dealing with that, okay? So we'll get into that in great detail later. I'll answer that question for you in about, I'll answer that question in about 6 months.
Cool. Excellent plan.
For Cal and Jess, I will answer that question for you in a year and 6 months.
Yay!
Okay? Okay. But yes, for now, don't worry about that.
Excellent.
That will be tomorrow's problem.
I like tomorrow.
Okay. Great. There are a couple other buttons up here next to the preamp I want to talk about. One is this red one that says 48V. What does that stand for?
48 volts.
48 volts. So what's that about? Well, not all microphones work the same way. I purposely got two out here, and you may not have looked very closely at them, and you might have thought they're the same thing.
They're not.
They're not the same thing. They're actually very different. The way you know they're different is because they sure put a different grill on them on this one. But other than that, they look very similar. But if I take the grill off, you will see that there's something very different going on inside these two microphones. Okay? So this is called a dynamic
I was
microphone.
about to say one's dynamic.
This is a dynamic microphone, which means it has a little diaphragm here that responds to sound amplitude pressure, and it moves that diaphragm inside of a electromagnet.
Okay.
Okay? And that's what creates the electrical pulse that goes down the wire. Okay? This is what's called a condenser mic.
Okay, condense.
And so it uses a capacitor, essentially. So it has a charged plate, a plate that actually takes an electrical charge, and then there's a little diaphragm next to that. And the audio signal is generated based on the capacitance between that diaphragm and the charged plate.
Gotcha.
The reason that is useful is that it takes a lot more work to move this big magnet than it takes to move that little wafer that's wiggling next to that charged plate, okay? So this mic tends to be a little bit better at fast, what we call transients. Transients are fast impulses of sound, which tend to also be high frequencies. So high frequencies are gonna really probably get a lot more detail audible on this mic than this mic. This mic can do it, just this mic does it a little easier. It's a lot easier for this mic to have a flatter frequency response than this does, because the condenser mic can respond to all the frequencies in similar ways, whereas the dynamic microphone isn't always as good at that. It's going to respond slightly differently to different frequencies. So most really flat, frequency response microphones are probably going to be condenser microphones, okay? So that's a quick little crash course in dynamic versus condenser mic. But some people sort of say, well, the condenser mic is also more sensitive, and it kind of is. We gotta be careful with words like sensitivity because that word means a lot of different things in the context of a sound system. But there is a way that you could look at this mic that you could say it is more sensitive. Generally, when you talk about sensitivity on microphones, you're talking about actual sound, actual air pressure converts to voltage. That's a sensitivity. How many volts comes out per Pascal. And that's not that could be what's happening. Condenser mic might put out more volts per Pascal, or might not, but it could. But in order for this to work, it just needs air, okay? But in order for this to work, it needs electricity. You have to have an electricity to charge up that plate that's in there so that it can register the capacitance.
In a condenser mic.
In a condenser microphone. So where are you gonna get that electricity from? Well, you can put a battery in the mic, and some condenser mics have the ability to put a battery in them. Or you can do this really clever thing, which is called phantom power.
Yeah.
And what phantom power does is there's a little circuit in here that will generate, it's generally either 24 volts or 48 volts usually, but mostly it's 48 volts. And it'll take that 48 volts DC signal and it'll shoot it down the XLR in a way that doesn't interfere with your audio signal. And that shows up here. And it can use that voltage to power that capacitor.
Gotcha.
Okay? So you push that, if that button is turned off, this mic doesn't do a darn thing. No matter how much I turn up this gain, nothing happens because there is no power. But if I hit the 48 volts, it now boom, charges up that plate, and now this can do something. Right? Chirp, 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 chirp. Right? We got something. Hello.
Hi.
Okay? Make sense?
Yes.
That's what that button does. But if I turn it off, then the mic is dead. Turn it on, mic works.
Why did it do that noise when you turn the power? Was it like anything specific?
Yeah, because it creates a little spike on the audio line. So yeah, you definitely, generally you don't want to do that when the mic's hot. I shouldn't have done that. Okay. Any questions about phantom power?
I have one.
Yeah.
Out of curiosity, how does it send voltage across the line without interfering?
So I don't really know. I've read about it a few times, and it's never entirely made sense to me.
Yeah.
Every time I think it makes sense to me, I think, oh, I think this is how it works, and then I go like, so, no, that's not how it works.
Magic.
So I don't really know. I've never really needed to know. I've been curious sometimes, where it's like, I wonder how that works.
That's exactly where I'm coming from.
But I don't really, you don't need to know that in order to use it. Other than, the only thing I do know about it is you can't run phantom power on an unbalanced cable.
Yeah.
So you do need a cable that has all 3 pins on it, like an XLR or a tip ring sleeve 1/4 inch that actually has 2 conductors plus a shield on it.
Gotcha.
So there's something about that. But if it just has a tip and a sleeve,
It's not gonna work.
it's not gonna work.
Gotcha.
Okay? So,
And you gotta have a XLR to 1/4 inch in order to make it, I guess, power and all
just for this you do.
Okay.
Like you could run phantom power down this adapter,
Okay.
right? Because it's got, it's got 1, 2, 3.
Right.
Right, signals on it. So yeah, I don't know, Cal. I've asked myself that question many times, and I've read about it many times, and I'm like, I still don't get this. I don't get how this works. Which I think is why they call it phantom power. It's just like it seems to just come from nowhere. I can't see it, I can't understand how it's happening, and yet it happens. So I don't know. Sorry, I wish I had a better answer. All right.
Geometry.
But it tells you something, that I've been doing this for a really long time, and I've never actually needed to understand that.
Yeah.
And yet I've used it a million times. All right, there's a couple other buttons here I want to point out to you. There's a button here that has a little screen printing next to it that has a little O with a slash through it.
Does that mean ground?
No.
What does it mean?
Well, that little symbol means phase.
Okay.
But here's the problem. Pushing this button doesn't do anything to the phase of the signal.
What's a phase?
I was about to say about phase, what are we referring to?
Yeah. Welcome to one of the most misunderstood concepts in all of sounddom, which is that we don't really understand what phase is. I think I understand it, but very few people do. So phase, if you think about one of the ways, so what's happening with sound or audio, so audio is sound in electrical form, okay? So what's happening in audio is you have this voltage, this alternating current voltage that's going between positive, negative, hot, cold, hot, cold, hot, cold. And that's what that's what translates into the push-pull on the air, okay? Well, that hot, cold, or push-pull happens over time. That's what makes sound, is that oscillating happens over time. Well, it does that in a circle. So it starts at whatever the resting state is, goes positive pulse, negative pulse, and then back to where it started. And that is a type of a circle. And so we can talk about that path in terms of degrees. So 0 degrees is where it starts, and it ends 360 degrees later. And that positive pulse is 90 degrees into the circle, that negative pulse is 270 degrees into the circle, and then halfway in the middle will be 180 degrees. So phase refers to where in that cycle are we?
Gotcha.
What phase of the wave are we in? Are we in the positive pulse phase? Are we in the negative pulse phase? Are we in the beginning 0 phase? Are we in the ending return to 0 phase? Are we in the halfway through that process phase? Or are we somewhere else, right? What phase of that process are we in? And that tends to correspond with time, because that happens over time.
Okay.
Well, I guarantee you that this button does not manipulate time.
Right.
Okay?
Not that one.
It absolutely does not. It cannot. It's just, it won't. It's not going to do that. That is not what it does. And yet, it is labeled phase.
So is there ever a reason or a point in time where we'll need to, okay, now you,
You will absolutely have reasons to push that button.
okay.
Let me tell you what it actually does. What it does is it inverts the polarity. Okay? What is polarity?
Right.
Well, polarity is is an electrical term. So a positive pulse, a positive alternating current pulse would result in that driver pushing out. Okay? A negative electrical pulse will result in that driver pulling back because it's a magnet.
Oh, so it's
Okay.
just switching the phase per se.
It's
Yes.
switching the polarity. So it takes that electrical signal and it inverts it upside down. So that everything that used to be a positive pulse is now a negative pulse. And everything that used to be a negative pulse is now a positive pulse. It just flips it.
Gotcha.
There are lots of ways to invert the polarity. You can invert the polarity by swapping the 2 wires around in the XLR.
Okay.
You could invert the polarity by on the back of a loudspeaker, taking the red wire, and instead of putting it on the red lug, put it on the black lug, and take the black wire and put it on the red lug. You would have inverted the polarity. Okay? So there's lots of ways to invert the polarity, but that has nothing to do with phase. So and now what is true, this is where it gets confusing, is that positive pulse in a signal that is not inverted polarity, that positive pulse can be identified as a phase of the wave, right? That positive pulse tends to happen at the 90-degree phase point of the oscillation. And that negative pulse does happen, happens at the 270-degree phase of the wave. But if you invert those things, that thing that used to be the positive pulse that is now the negative pulse is still happening 90 degrees into the phase of the wave, right? We haven't changed the phase. We're still in the same phase of the wave. We've just had to go a different direction now at that
Okay.
phase, okay?
Yeah, that makes sense.
And so this is why, but it gets confusing, because if you could somehow offset the phase, if you could manipulate time in such a way that you could shift that phase so that that positive pulse that used to happen at this time now happens a little bit later, then you would now have that and be at a different phase relationship. That positive pulse would be happening at a different phase and therefore be opposite of the negative pulse. It's possible to do that. And you can delay signals digitally in a way to accomplish that, which could result in a cancellation if you sum the two signals together. And one of them, you just delay one of them slightly. And if they are sine waves, in other words, pure tones, that just have one frequency in them, then yes, you can delay them by manipulating the time of one of them. You can cancel them out by manipulating the time of one of them. Okay? And if you invert the polarity of a sine wave and sum it together with a copy of itself, you get the same result. But you did something fundamentally different to get that result. You did two different things to get the same result. Here's the problem. We never work with pure tones. We never work with sine waves. The only time you ever encounter a sine wave is when you have a feedback frequency, okay? And we get rid of those. We don't let that happen, okay? So every other sound we have is a complex tone. If you invert the polarity on a complex tone and sum it with a copy of itself that is in polarity, everything goes away. All the frequencies cancel out. If you manipulate the time of a complex sound that has multiple frequencies and sum it together, some frequencies will be in opposition and some will not, based on that time shift. And so some things will go away and other things will not. It's called cone filtering, which we will talk about more in sound system design. So these are complex tones. And there's absolutely nothing that I can do with that button that will manipulate the phase and cause cone filtering. But what it can do is invert the polarity. So why would you ever push the button?
To invert
To invert the polarity. But why would you need to invert the polarity? Well, there are a couple of reasons. What's that?
You wired one of your speakers backwards?
Yeah. Maybe one of your XLRs got soldered incorrectly. And pin 2 and pin 3 are swapped on one end of the XLR. That could mean when you put a positive pulse on this mic, it shows up as a negative pulse at the mixer. And then you mix those, and let's say these two mics are pointed at the same thing. And this one is positive polarity, this one's negative polarity. You mix them together in the console, what's going to happen? Cancels out, and you're like, where's the sound go? Okay? Well, you can fix that problem by doing one of two things. You could figure out that the XLR is wired backwards on one end, and you could take it apart, resolder it, fix it, or maybe you could swap out the XLR, which if it's a couple of feet like this one, no big deal, but if it's running 300 feet down the aisle of the theater in the middle of the show, you don't want to go, it's much easier to just go, you know what, I'll just invert the polarity of the console. And, and it just solves the problem, okay? Some other things that can happen is, yeah, you could have a loudspeaker wire backwards, or there's lots of ways polarity could get inverted in one way or the other. And this is just a quick way to solve it. That's all it is. Just a quick way to solve a quick problem. But it's also a problem that, until you really have done this for a while, you're almost never going to realize that that's what your problem is. But it does happen. But there are people that tell you, oh, you got to mess with the phase. No, it's not messing with the phase. So it's not for that. It's only for that weird situation where you've got a polarity inversion. Okay? Any questions about that? Agree with me on that? We're doing okay? Mm-hmm. We got a little bit more time. Let's get this thing done.
40 minutes.
Yeah. You see, we're getting it. We're not very far. We're now. We just barely got past. We're not even past the input preamp stage yet. Okay, so we're taking a slow walk here. All right, we've gotten the signal in. We have amplified it sufficiently. We have energized the microphones that need phantom power, and we have dealt with polarity inversions that may or may not have occurred. Great. Now we've got good signal. The signal is coming into the board in the condition that we need it to be. Okay? Now we can start messing with it, which is now what the mixer does, is let you mess with it. But most of your work, you spend, if you're doing this right, you're going to spend a ton of time just getting the signals into the mixer in the right condition. And if you skip that step,
Everything is.
nothing is ever gonna be good because you're starting with garbage.
Right.
You know, you're starting with a problem out of the gate, and then you're gonna mess with it. It's like, no, you're messing with a problem. You know, you're only gonna make that worse. You're never gonna make it any better because it's starting out bad. So you wanna put a lot of work into getting it right. Get the right cable, use the right input, get the gain preamp set to the right place, energize the mics that need the phantom power, invert the polarity to correct for any, you know, cable wiring issues, and then you're good. No clipping, everything's clean, high signal to noise ratio, everything's awesome. And guess what? If you do this right, odds are you may not have to do anything else. I may just need to go. I have a show. Excellent. All this other nonsense doesn't matter. Okay?
Excellent.
I'm telling you. Like, put as much effort as you can into this. And then all this is a piece of cake. Okay? It's when you skip over these steps that suddenly you're like, oh crap, you know, this is in the wrong way and I gotta boost this more and I gotta hum, so I'm gonna EQ that, or like this is where you get yourself into big trouble. But
Let's
get,
watch this one.
yep, get this right first, and then go straight. All right.
Well, your camera went out of focus.
Yeah, because I probably stand in front of it. Let's see. There you go. All right. So in our last few minutes here, I want to talk about the next thing that we encounter. There is a little button here that is still part of this preamp section. And it says 100 hertz. It has a little line above the 100 hertz, and then a little diagonal line next to it that goes like that.
Okay.
What does that mean? That is called a high-pass filter. And what it does is, when it says 100 hertz, well, let me tell you the simple explanation, and then we'll get into what's really going on. The simple explanation is, it is going to cut the frequencies that are lower than 100 hertz and not let them through to the rest of the console.
Okay.
Why would you want to do that? Well, in my experience, one of the things that you will battle a lot is what I call bleed. A lot of people call it bleed. The bleed is sort of like, you're gonna put all these microphones out here, and you can't, it's really hard to get this microphone to not pick up things that this microphone is picking up. Okay, they're gonna share some information. And in a perfect world, they would not. Because when I bring up this fader for the bass, I only want to hear the bass. I don't want to hear the kick drum that's right next to it. Okay? And so, but sometimes, you know, often, you know, it's really hard to get those perfectly isolated. And generally speaking, it's the low frequencies that bleed the most because they're the least directional. The low frequencies tend to just go everywhere. The high frequencies, you can focus, it's much easier to control them and get them to go where you want them to go. But the low frequencies really just go everywhere. And so one of the ways to help with that isolation is to engage those filters. So if there's nothing on that signal that you need in that low frequency spectrum, then turn that on, because that'll help with some of that isolation. Another thing that I find sometimes happens is even if the bleed is not a concern for you, suddenly, you know, like maybe that's not causing you problems from a mix point of view, but if you then bring up a whole lot of signals that have a lot of that low energy that you don't need, and it's picking that up on all the microphones and sources, you mix it together, all of that low energy gets amplified 1,000,000 times inside the console because you've just made 20 copies of it. And then it comes out and your system sounds really like bottom heavy. because of all that low frequency that's kind of building up and just like picking up on all the mics, and then you mix it all together. And so even if you don't care about that isolation, sometimes being able to just say, no, I don't need that here, I don't need that here, I don't need that here, can really save you a ton of time later when you get to like EQ your system, okay? Because you're EQing around what is ultimately an issue of bleed. So let's take a look at what kind of things we might use this for. So I have this, which is my bass or kick drum. I probably want the low frequency on that, right? So I'm not gonna do it. This is my snare drum. There's not a lot of low frequency energy that I care about there, right? Well, there's some toms there a little bit. But let's see if I turn it on, do I miss anything? I don't miss anything there. I'm fine with that. I can quite happily go without that. Great. What about this? This is mostly cymbals, right? Yeah. Don't need any low frequency there. It's a piano. I mean, there could be some low energy I would care about there, but it doesn't sound like we're doing any of those kind of things. So I think I can get away without that. Great. If you can get away with it, do it. Bass, I probably need that, right? I want to leave that. Acoustic guitar. I'm not missing a lot there. I'll go ahead and give that. Let's see. You hear a difference. Is it a difference I care about? Just depends. Like you can hear it. It's like, okay, do I care about that? Do I not care about? Would I rather have that, or would I rather have a cleaner mix? You know. In most cases, I would say I want the cleaner mix.
Right.
I don't need that. Right? So that's just a quick way of like getting rid of that low frequency energy that tends to like get out of control really easily before it goes anywhere else. And now I can take this in. And already, this is better. Okay. It's nowhere near as yucky on that low end. Okay. And all I did was hit a few. I'm not filters. Okay?
And you pressed.
Well, L button.
Okay.
Now, the slightly more complicated answer to what this thing does. It doesn't, it's not a brick wall. It's not like nothing, it's not like 99 hertz is not gonna be there when you hit that button. There's a ramp to it. So what happens is 100 hertz is the frequency that is 6 dB quieter, or 3 dB quieter, depending on what kind of filter it is. So it's actually going to start affecting frequencies sooner than 100 hertz, and there's a decay to it. Mm-hmm. So there will definitely be frequencies lower than 100 hertz that'll be let through. They will just be significantly quieter, and eventually you'll get to a point where it's attenuated completely. So I just want you to understand that it's not a brick wall. It's not like you hit that button and you have nothing 99 hertz and below. There's a tail on it. Okay. Which is how you can get away with things like on that electric guitar, like, oh, I'll just put that in. There's a little bit of low end. It's not gonna make it all go away, but it's gonna tame this a little bit, make it a lot easier to mix, okay? And now I can bring it up. And I can do this, okay? Can't tell you how many shows I've done where I'm just like, oh, this is a mess. And I'll just go through and I will hit as many of those high pass filters as I can. And suddenly it's like, oh, okay, I have something now. Excellent. Okay? So use that. Some consoles will give you the ability to control where that cutoff frequency is. You'll get a knob or a toggle button to choose between a few different things. So play with that. See which one works best. This one is 100 hertz. This one's 100 hertz. Sometimes it's 80 hertz. Sometimes it's 120 hertz. Sometimes it'll let you decide with a knob. But super useful. Okay. Everybody with me? Have I left anyone in the dust? Doing okay? All right, looks like we can do a little bit more. All right, the next thing you encounter as the signal goes through here. is what's called the EQ section, or the equalizer section, or the filter section. First of all, if it's hopefully, you okay?
Yep.
Hopefully, if you pay enough money for the console, they will give you a button that will bypass that EQ. And that is very important for a couple of reasons. The equalizer allows you to manipulate the frequency spectrum, which we'll hear what that sounds like in a minute. But remember that one time when I said every electrical circuit has noise when you try to make sound with it? Every electrical circuit makes noise when you try to do sound with it, including every single one of these circuits that are controlled by these knobs. Whether you have them set to 0 or not, they have noise. So if you are not using the EQ, it would be super nice to not have to run your audio through it
Okay.
and pick up that extra noise. Okay? So it's worth paying, if you, especially in the analog world, it's worth paying a little bit extra money for something that lets you bypass those EQs, because your sound will be much cleaner if you don't have to run it through that when you're not using it. Okay? So this one certainly has it. I've got them all bypassed right now. But let's play around with this and let you hear what we're doing. So if I go ahead and hit the button and turn this in, I have ultimately 4 filters on here. So I have what's called a high shelf, and a high shelf will either boost or reduce a swath of high frequencies. And in this case, I don't get to control what high frequencies it does. It's a fixed thing. But let's hear what that sounds like. Okay. Can you hear the difference? If I take it down. So I'm getting rid of all those high harmonics, those high frequencies. I'm gonna make it really loud.
Oh, okay.
And then there's the opposite of that, which is the low shelf, which does the same thing but for a swath of low frequencies. Low frequencies, right? Versus less low frequencies. Okay?
This is so cool.
Okay. Then I've got these 2 in the middle that are called semi-parametric. And parametric just means that you get to control what happens a little bit more. So a fully parametric would let you select the center frequency. It would let you adjust how wide of a chunk of frequencies you're going to manipulate, and then it will give you a control to either make it louder or make it quieter. This is semi-parametric in the sense that it allows me to select the frequency, and it allows me to make it louder or quieter, but it doesn't allow me to adjust how wide the range of frequencies are. That's a fixed thing. It's a fixed block that I'm just shifting up and down the spectrum to the area I want it, and then I can mess with it. So let's see what this sounds like. So if I take it up to, I can go between 550 hertz and 13 kilohertz. Now, if you don't know what those sound like, do sound check. Okay? But I'll take it down to 550. Okay, that's 550. That's not 550, but it's taking a lot more than 550 hertz of it, right? It's taking a whole swath of sound, right? Now I can take it up to 3 kilohertz center frequency. I can boost or I can cut. So that's what that does. And then this is another one, and this one ranges from 80 hertz to 1.9 kilohertz. So it's just allows me to range in a lower area. So if I go to 80 hertz, right, I can take it to 450, which is really close to the 550, right? So on and so forth. This just allows you to kind of tune the signal a little bit. Here's what I found that happens a lot is most things that make sound in real life, all the different frequencies don't come from exactly the same place.
Right.
You know, like our voices, for example. All the frequencies that make up our voice sound like our voice. They don't come from the exact same place. They don't necessarily all come from that spot in our mouth. Sometimes it comes out of our nose, sometimes it goes out of our ears, sometimes it, you know, kind of wraps around our head a little way, different ways and stuff like that, and it kind of becomes the thing that's us when you get a little farther away. That all kind of like merges together. Yeah, but if you put a microphone really close to me, it doesn't always sound the same way because you're so close, and those frequencies haven't quite merged exactly the way they normally do. And that can happen with a voice or an instrument or lots of things, which is why you kind of play around with, okay, what sounds best, because you're trying to figure out where to put the mic to get it to sound the most like the thing. You don't always have control over where you put the mic. Sometimes it like has to go in a certain place and whether it sounds good or not. So sometimes when you have that situation and you're like, oh, well, I'm not really picking up the frequencies entirely intact, you can use that EQ to sort of like correct for that, to try to artificially rebalance that thing to get it to sound. So I spend a lot of time doing that, whenever, especially when you put little tiny mics on actors' foreheads and you move them around, you can put it different sides of their face and stuff. It sounds very different. So wherever the pretty committee allows you to put it, and you know, it sounds best right here, but if the pretty committee doesn't let you do that, and you ended up having to put it over here, for example, you know, the high frequencies are not gonna wrap around their face very well to get over here. So you're gonna have a lot less high frequency coming in. And so what you're gonna wanna do is use the EQ to help correct that.
You're talking about a lav mic?
Yeah, but here's the thing. Watch something here, let me show you something. So here's our piano again. Let's say I'm like, hey, I want more low end on this thing. Oh, let me pop it in. Great, I got more low end, but what did I do?
Clipped.
It's clipping. Why is it clipping?
Just added ball.
It's clipping because I just spent a whole lot of time getting that knob exactly the place it needs to be so that it's as hot as it can possibly get without clipping. And then what did I do? I turned something up.
Oh, so we do pressure.
EQ has
So don't use the EQ to turn things up. Only use the EQ to turn things down.
Okay.
How would you
Okay.
suggest then to have the lower parts of the piano heard better?
So you have to think about this. Okay, if I'm feeling like I need more low end, another way of thinking about that is I need less high end. Okay, so instead of boosting the things you don't have enough of, reduce the things you have too much of.
Got you.
So always reduce, don't boost. Okay, because if you do everything I told you to do with your preamps, boosting EQs is gonna cause clip distortion. And that's that's one of the reasons why the people on YouTube tell you to just set it at 12 o'clock and forget about it, because then that gives you some room to do boosts on your EQ without having to worry about clipping. And I'm going, yeah, but now you got a hissy sound.
Right.
Okay, I would much rather just get better at EQing, right? I'd just rather learn the frequency spectrum better so I can understand what to reduce instead of what to boost, okay? So you can play with these. If you want to sit and play with these, you can in our last few minutes. So I'll give you like an example of something I might do, like here's this kick drum, right? I might say, I really want this to feel more thumpy, right? Well, to make it more thumpy, I'm gonna get rid of some of this high frequency, right? Maybe even reduce some of this. Right? As opposed to that. And then when I pair that with the other stuff, the other drums, I'm getting a better thump out of that kick drum that doesn't conflict with everything else, as opposed to.
It just sounds so like, I don't know.
So that's an example of just sort of like an artistic thing you might do, but I did that by cutting things, not boosting things. I didn't like boost the low end. I cut the high end. Okay, and that makes it sound more thumpy. Okay?
More dumpy.
How we doing? Everybody okay?
Yes.
All right, I think that's probably it. So we gotta take this stuff down now. So we'll set this up next week and we'll keep talking. We'll do more, okay? Any other questions before we take it down? All right. So here's a couple of things, just be aware, when you got like this, always turn off the amplifier first. That way you don't have those pops when you stir it. So I think that's off, we can shut it all down and we can put this all away. So just unplug it all, just go wild.
Leave this on.
Leave this on or?
You can turn it off, you can unplug it, do whatever you want to do.
Trying to figure out where
Put it all
to
It should be
Oh, right
on.
here. Boink.